What does it take to create an amazing modern-day cathedral? Our next guest is from the design firm that did just that. He's Associate Director from Skidmore, Owings, and Merrill, Mark Schwettmann. Mark, welcome into Tomorrow. How are you, sir?
Great. Thanks for having me.
It's a pleasure. Kudos to you and your team. I mean, we talk about awe-inspiring designs. We talk about something that we saw originally, just the model, a few months back at Autodesk University when we were broadcasting from there in Las Vegas back in December. And that's amazing in and of itself. I mean, just the 3D model. And it's like, oh my gosh, somebody actually built this. Then we had the opportunity just yesterday as we came out to San Francisco to cross the bridge into Oakland and visit the cathedral. It's the Cathedral of Christ the Light. You've got to check out the video, which if you're watching on our videos right now, you're seeing the incredible work and beautiful, awe-inspiring design of this cathedral. First of all, Mark, tell us briefly, what type of work does your firm do other than beautiful cathedrals?
Well, we're a international firm, and we have offices all around the world doing architectural projects all around the world. We're interdisciplinary, so that means that in addition to architects, we have structural engineers, we have mechanical engineers, we have urban planners, graphic designers, pretty much everything that goes into designing the world around us.
And tell me now specifically about this cathedral. What went into this design, which there are so many elements. It's like, how do you start? But you must be able to figure that out.
Well, the cathedral was an incredibly exciting opportunity for our office. The design was led by Craig Hartman, who's a design partner here at SOM San Francisco, and really goes back to a design competition, which was many years ago. And so our team was involved in everything from the initial concepts about where it would sit on the side and what form it would take, down to literally detailing the shape of a door handle. So it was an incredible opportunity to do something from the very big to the very small.
How is it, do you think, Mark, that computer technology specifically has changed the architectural design process in general and your jobs in particular?
Well, it's really changed almost everything about it, and the rate of that change is accelerating. It's every day and every month we're finding new ways to work. I think the cathedral is a great example. The project team on that was using 3D modeling from the beginning to understand the form and really to conceptualize the form, which is really kind of an evolution of thought about sacred geometries. And that space of the cathedral is actually the intersection of two spheres. So you take two spheres and push them together, and the shape that results from that is the form of the inside of the cathedral. So studies are done three-dimensionally to evolve that concept down from what it looks like in the big picture to individual pieces of wood and glass that form the walls. Some of the elements that you saw there's a wall at one end of the space, which is called the Omega Wall, which has an image of Christ, a historical image. That image is actually made up of almost 100,000 holes cut into aluminum panels.
And this is where natural light, because of your design, is actually illuminating the picture.
Right, and every part of the cathedral was thought about in the context of light. And we use computer technology to simulate that, to see what it might look like at different times of day and with different lighting conditions. In the case of the Omega Wall, our team developed a custom tool to translate an ancient image into, as I said, 100,000 holes of different sizes. And so in the daytime, you see light coming through it. In the night, you see light from the inside. And it really changes its character over the course of the day.
So these are almost like physical pixels, unlike the pixels, maybe not unlike the pixels we would see on a television display, but in this case, they're cut. Holes cut in the structure.
They're like backwards pixels in a way, and instead of a light behind your television, you have the sun.
Amazing. And again, we talk about awe-inspiring. It's almost like you can't find the words except just wow when you look at this kind of design. And how tall is that? The Omega Wall. It's almost like 3 or 4 stories, it seems, if you were to relate to a normal building.
Well, without knowing the exact height in feet right here, it's more than that, certainly. It's like a 7 or 8 story building, probably.
Amazing. It truly is wild. You got to check out the video on our site. And of course, what's next then, do you figure, as we head into tomorrow? What other design elements are you guys using now and certainly looking forward to as we progress?
Well, what we've really seen is an evolution of how computers are used from just doing what we did before better. So we used to draw by hand, then we could draw with a computer, to building models in the computer that are smart and that understand what they are. And so there's one step there where, which we're really doing actively now. You've probably talked a lot on your show about BIM today, or you will today, where a piece of your model knows it's a wall or knows it's a floor. And from that, we can really automate the process of making all of the drawings and coordinating with all the people who need to build a building. What we also think is really exciting, though, is in a way going beyond that and engaging computer tools early in the process to let us make buildings that are performing better than we could by any other way. So a building that we can optimize to let light in only when you want it to, or a building whose entire form is derived from making sure that a public place isn't too windy, or a building whose shape forces the wind through it to cool it at night and release that energy back into the day. And these are things that we can't do without computer technology.
Very easy website to visit to see what Mark and his team are up to and what Skidmore, Owings, and Merrill are working on, som.com, and you'll see some more of the cool things that they're doing. Mark, thanks for spending a couple of minutes with us here. We'll talk more in the future, I hope, because there's so many cool things you guys are working on, especially with Autodesk software and neat things.
All right. Thank you very much.
We're back with more as Into Tomorrow continues. This is Into Tomorrow on the Advanced Media Network. I'm Dave Graveline from San Francisco in the Autodesk Gallery. Don't go away.